Okay, so today I'm going to talk to you guys about the metric system and how to do something called dimensional analysis. So I'm kind of going old school here with a piece of paper, but go ahead and follow along here. So how do we measure things? First off, in the metric system, we measure length, mass, and volume are the three things we measure the most. Length, we're going to use meters. Mass, we're going to use grams. Volume, we're going to use liters. Okay, so these are the base units in the metric system. Abbreviation for meters is lowercase m, abbreviation for grams is lowercase g, and the abbreviation for liters is a capital L. Okay, so these are the base units. Now, the way the metric system works, everything is based off of these units, and they have prefixes. The prefixes tell you exactly. The prefixes tell you how much bigger or smaller they are than the meter, the gram, or the liter. Okay, now there's a lot of prefixes in the metric system, so I'm going to give you guys a website here to click on and open up to check it out. I've also got a link in Buzz for this, so you can click on that link. It opens up this website. This website will be in the resources for the rest of the trimester. This link to this website, so you have access to these prefixes, so you need to know what these prefixes are. Now, the way they showed you how to convert in that video you watched a few days ago, basically they said something similar to King Henry died unexpectedly drinking chocolate milk. So this is the prefixes. This U stands for unit. Okay, so this is actually going to stand for either gram, liter, or meter. And then the rest of these stand for the prefixes. These are all bigger, so kilo, hecta, deca. And then these are all smaller, deci, centi, milli. Okay, so the way they showed you here, if you have 2.3 kilometers and you want to know how many meters that is, well, kilometers right here. Meter is right here, it's the U. Okay, so I'm going to go from kilometer to the U. So I go 1 step, 2 steps, 3 steps to the right. Okay, so I take my decimal place and I move it 1 step, 2 steps, and then I add a 0, and then 3 steps there. So that's 1 around the 3, and then 2 more steps, sorry. So that would be 2300 meters. So that's how you can convert by just moving this decimal place here in the metric system. So I'm going to do it again. This time I'm going to convert 5.47 grams to kilograms. So I have 5.47 grams. I want to know how many kilograms that is. Well, King Henry died unexpectedly drinking chocolate milk. So I'm going from gram, that's the unit here. Remember that U stands for gram, liter, or meter, all the way up to killi right here. So I'm going 1, 2, and 3 steps to the left. So I'm going to take this decimal and go 1, 2, 3 steps to the left. So that's 1 spot, 0, 0 for decimal there. So 0.00547 grams is how many kilograms, is how many kilograms that would be. One more. King Henry died unexpectedly drinking chocolate milk. Okay, I've got 2.34 grams. This time I want to go to centigrams. So I'm going from gram to centigram. I'm going this way, 2 steps. So I'm going to move it 1, 2 spots. So that would be 234 centigrams. All right, so this one's a little longer. Cut that. Drinking chocolate milk. Okay, so this time I have 6.59 centimeters, and I'm looking for kilometers. So here's the centimeter, here's the kilometer. So that's 1, 2, 3, 4, and 5 steps to the left. So this one's a little bit longer, so I'm going to go 1, 2, 3, 4, 5 steps to the left. So that's going to be 0, 0, 0, 0. So this would be 0.0000, 4 zeros, 659 kilometers. Okay. Now, that method works great for small things like milli to milligram to gram, or kilogram to gram, or kilometer to meter, or centimeter to meter. So a couple of those somewhat short ones here. But when you get into something a bit more complicated, for example, going from centimeters to inches, I mean, we're going from the American system to the metric system here, this can get a bit more complicated there. So I'm going to teach you guys how to do something called dimensional analysis. Okay, so 1 inch is equal to 2.54 centimeters. Right, that's the conversion between centimeters to inches here. Now, dimensional analysis works like this. Okay, I'm going to take my number that I'm given, 8.55 centimeters. Okay, now I'm going to times this by something called a factor. Sometimes this is called factor labeling. Okay, now because these are equal, okay, if I actually have 1 inch over 2.54 centimeters, since they are equal to each other, this right here, this factor, an inch over 2.54 centimeters, that is the exact same thing as saying 1. Okay, an inch over 2.54 centimeters is 1. These are equal, so 1 divided by the other is 1. So basically, if I take this and I times it by 1, but I use this factor here instead, 1 inch over 2.54 centimeters, I'm basically timesing 8.55 by 1, okay? But these numbers here, since they're equal to each other, they will actually convert it. Now, there are actually two possibilities when using a factor. You could have an inch over 2.54 centimeters, or you could have 2.54 centimeters over 1 inch. That also equals 1. Okay? I don't want to use this one in this case because centimeters is what I have. And so what I want is to be able to take the centimeters, times it by inches, and then I'm going to divide it by centimeters. And that is actually going to cancel these centimeters. So if I take this 8.55 times 1, and then divide that by 2.54, clear here. So 8.55 times 1 divided by 2.54, I get 3.36614, kind of a whole bunch of numbers there. I'm going to round that to 3 significant figures because that's what this has. All right, and this is a conversion, so that's what they are equal to. So that one is infinite sig figs, both of them. So I'm going to round that to 3.37 is how that's going to go. 6 rounds it up. Now, the units here are inches over, centimeters times inches divided by centimeters. So, because it's centimeters times inches over centimeters, the centimeters is actually being divided by centimeters, so I am left with just inches, which is what I want. So this method here, I know that what I just did is kind of complicated, but we are going to do some extremely complicated conversions here in just a few minutes. So I'm going to try to show you this method of how this dimensional analysis works, and then we're going to get into a few very complicated conversions here. Okay, I'm trying to show a somewhat simple one here, one that you guys are probably like, yeah, that's a lot of work. But let me kind of show you the process, and then we can get into one of those more complicated ones. So essentially, I'm taking the number, timesing it by a factor. That factor is basically this, what they're equal to, one over the other, and I'm making sure that when I do that, I'm putting the centimeters on bottom because I have centimeters, so that when it equals at the end, centimeters is divided by centimeters, and I'll be left with just inches. Okay, so it's 3.37 inches is my answer here. What if I wanted to convert from meters to miles? Okay, so what I'm going to do here is I'm going to take what I was given, 3.55 times 10 to the power of 5 meters. I want to know how many miles that is. I'm telling you right now, 1 mile is 1,609.34 meters. Okay, so I'm going to take this one and I'm going to times it by a factor composed of these two numbers. Since I have meters, I'm going to put the 1,609.34 meters on bottom. That means that I'll have meters eventually divided by meters, so that unit will cancel. And then the 1 mile on top. Remember, 1 mile and 1,609.34 meters are equal, so I'm timesing it by basically 1 here. All right? It's just different units, so I'm changing the unit. So it's the same value, because I'm timesing it by 1, same length, but it's going to be a different number. I'm just going to have a different unit here. So basically, it's all about changing the units. So I'm going to take this, and I will be left with miles, which is what I want. So 3.55 times 10 to the power of 5 times 1 divided by 1609.34 is a really long number in my calculator. Now, sig figs. This is how it's defined. So this here is my number. It has 3 significant figures. I'm actually going to round this so it has 3. So I'm actually going to round 2 to the 0. 5 rounds it up, so 221 miles. Okay. Okay, this time I'm going from 4.8 gallons to liters. Gallons to liters here. So, converting from the US to the metric here. So I have, start with the number I'm given, 4.8 gallons times it by a factor here. Factor is composed of these numbers, this conversion here. So gallons is what I have, so I'm going to put the 1 gallon part on the bottom, and then 1 gallon is equal to 3.78541 liters. Gallons divides by gallons. When I take this and I divide by that, I'm left with liters. So it's going to be 4.8 times 3.78541 over 1. Right, dumps that into the calculator there. And I get 18.169968. This has 2 significant figures. This is how it's equal, so those are infinite. So I'm going to go with 18 liters. 2 significant figures. Okay. Now, so far you might be going, hey, this isn't too bad, but it's a lot of work for kind of what we're doing here. So let's show you how this can actually get a little bit even more complicated. So I've got 5.6 feet. I want to know how many centimeters that is. All right. Well, 5.6 feet is where I'm starting. I want to know how many centimeters that are. So first I'm going to times it by a factor. Now I know that 1 inch is equal to 2.54 centimeters. That was one of the earlier examples I used. And I know that 1 foot is equal to 12 inches. Okay? So what I have to do in order to get the into centimeters, since it's inches here, I'm actually going to have to convert feet into inches and then inches into centimeters. So this is going to be a 2-step, kind of like I did earlier. So what I'm going to do here is I'm going to take the 5.6 feet, and first I'm going to use this one. So I'm going to have the 1 foot on bottom so that feet cancel. And I'm going to have the 12 inches on top. In my next step, now that I have inches, I'm going to take the 1 inch on bottom. So it cancels. And then I'm going to have the 2.54 centimeters on top. Okay. 5.6 times 12 over 1 times 2.54 over 1. And I get 170.688. 2 sig figs, this is how these are equal, so they're infinite. This is how these are equal, so they're infinite. So 2 sig figs here, so we're going to go 170 centimeters. round to this figure. Okay, to the 7, so the 0 rounds down. Okay, so for this next example, I'm going to convert 16 ounces to milliliters. Now, this one gets kind of complicated here. I know that one gallon equals 3.78541 liters. Okay, well, I don't have gallons or liters up here. All right, but that's how I know they kind of convert from one system to another. But I do know that a gallon equals 128 ounces. So with this information, I can actually take the 16 ounces and figure how many gallons I have. And then I can take the gallons that I have and figure out how many liters I have. And that'll at least get me to liters. And then I know in the metric system how many milliliters are in a liter. So this is going to be a little bit long here. So I'm going to start with what I'm given. Always start with what you're given. 16 ounces. And I'm going to use the conversion with ounces in it. 128 ounces is equal to a gallon. So I'm going to put the 128 ounces on the bottom, so that'll be ounces divided by ounces. And then that's equal to 1 gallon on top. Okay, so that's my first part. Next, when I get rid of this gallon, I have gallon here, and that equals liters. Okay, so I'm going to put this 1 gallon on bottom so that it cancels. And I'm going to look for the 3.78541 liters. Okay, so now I've got liters, not gallons, but I want milliliters. Well, 1 liter is equal to 1,000 milliliters. That's how they're equal. Or you could think of it as 0.001 liter is equal to 1 milliliter. Okay, you could also put that up there and get the exact same answer. And that will make liters divided by liters, so that will cancel. All right? Calculator. 16 times 1 divided by 128 times 3.78541 over 1 times 1,000 over 1 equals 473.17625. This only has two significant figures. So this is how this is equal, this is how this is equal, this is how this is equal. So let's have infinite sig figs because that's how they're defined. So it's two significant figures here would be 470 milliliters. Okay? Got 3 steps to get there based on what I knew. All right, so this next example, the wavelength of red light is 700 nanometers. How long is this in inches? Okay, well, I know that an inch equals 2.54 centimeters. All right. But I don't have centimeters, I have nanometers. So I got to figure out how nanometers and meters and centimeters are related. So I look it up on that one sheet and I find out that a nanometer is actually 10 to the power of -9. So that's what a nanometer is. So 1 nanometer equals 10 to the power of -9 meters. Okay, and then I know that there are centimeters, there's 100 of them, okay, because 1/100. So you can either do 0.01 meters is equal to 1 centimeter, or you can do there are 100 centimeters in 1 meter. It really doesn't matter, okay? Whichever one you use, these are both the same idea, right? So I'm going to take what I was given, 700 nanometers. Start with what you're given. And I want to get rid of that nanometer, so I'm going to put the 1 nanometer is equal to 10 to the power of -9 meters on top there. Nanometers divided by nanometers makes it go away. Next, since I don't actually want meters, I'm going to convert the meters into centimeters. I don't want that either, but we're getting there. So I'm going to go with the 1 meter is equal to 100 centimeters. And I'm going to put the meter on bottom, whichever one I use. Now I have centimeters. Okay, go another step here. Centimeters to inches. All right, well, I have 2.54 centimeters on bottom, so that's centimeter divided by centimeter, and then 1 inch on top, and that finally gets me what I'm looking for, inches. All right, punch this into a calculator. 700 times 10 to the power of negative 9 over 1 times 100 over 1 times 1 over 2.54. And the answer is 2.7559 times 10 to the power of negative 5. I only get one sig fig, so I'm going to go with, because that only has one, 3 times 10 to the power of negative 5 inches. Okay, so this example here, I have kilometers per hour to meters per minute. Now this one gets a little confusing here because I got the whole per hour thing going. So I'm going to start with what I'm given, 2.5 kilometers per hour, 2.5 kilometers, and this time it's actually a factor itself, per hour. Okay? So this one is really going to pay attention to exactly how this factor is set up. All right, so 2.5 kilometers per hour is what that is. Now, what I'm aiming for is meters per minute. All right, so first thing I'm going to attempt to do is I'm going to turn the kilometers into meters. Okay, so I'm going to try to get rid of this kilometer by putting kilometer on bottom. And I'm going to look for meters. Okay, if I remember that metric system, there are 1,000 meters in 1 kilometer. Okay, so kilometer per hour will be times by 1,000 meters per 1 kilometer. Kilometer is being divided by a kilometer there, so it will cancel. That will get me my meters, okay, but will not get me my minutes from the hours. So this next part, got to think very carefully. I don't want to change this meter. I do want my final answer to have meters, but I want it to be minutes down here, okay? So don't want to touch that meter, but I do want to change this hour. Now, since the hour is down here at the bottom, I'm basically dividing by an hour already. I don't want to put hours down here, because if I put the hours down here, then I'm going to eventually not end up with minutes, but I'm going to end up with hours squared, which is not what I want, okay? So don't put the hour down there. What you want to do is put the hour up here, opposite, okay? So if you have an hour per hour, times it by an hour, and then minute down here. So how many minutes are in an hour? There are 60 minutes in 1 hour, okay? So this will get me my meters. Oops. Hours divided by hours. Minutes is what's left. I'm sorry. I didn't mean to cross that off. Okay, this will get me my hours gone, and it'll leave me with per minute. All right, so I'm going to take this and punch it into a calculator now. So 2.5 times 1,000 over 1 times 1 over 60. So this is going to be 41.666 repeating. This is how they're defined, and this is how they're defined. So infinite sig figs, but this one only has 2, so I'm going to round that up to 42. So it's 42 meters per minute. I'm going to show you another one like that, because that's a little confusing. Okay. So I've got 32.1 meters per minute. How many centimeters per second is that? Okay, so 32.1 meters per minute. First, I'm going to attempt to get rid of this meter, turn it to centimeters. So get rid of the meter. Since I have it on top, I'm going to take it and I'm going to divide it by meters, so it cancels. And I'm looking for centimeters instead. There is, in 1 meter, 100 centimeters. Okay. Next, I want to keep the centimeters, don't change that, but I want to get rid of this minute. There are 60 seconds in a minute, so I don't want to put minutes on bottom because minutes is already on bottom. I'm going to put the 1 minute on top so that it's going to be divided by minutes times minutes, they will cancel each other. And then I'm going to put these 60 seconds on bottom. Okay. So 32.1 times 100 over 1 times 1 over 60. 53.5. Okay. And that one has 3 sig figs, which I started with 3 sig figs. This would be centimeters per second. And that's how you do dimensional analysis.